Recording is on. Yeah. Okay. So I noticed that I couldn't elaborate on this accessing of arrays using pointers. I may have briefly explained this, but I don't think I had given you a detailed description. So let me take the pen. Still a certain amount of students who haven't turned on their videos. So before we start, can you please turn on your videos? Kavinda, Kumara, Siri, Rishad, Jayakodi, Snifa, Hettiarati 3604, Anthony 353. Because we're gonna, the time is ticking. I'm gonna go to the lessons. 3530 Anthony, your video is not on, and there's a couple of others as well. So I expect all of you to turn on your videos. I'm going to go to the lesson. Yeah, please turn on your video. So people, so over here, I mentioned the last time when we are accessing arrays. So for example, when we create an array like this, essentially what we are doing is we are creating an array. So in this case, we are creating an array of 5 of size 5, 1, 2, 3, 4, 5. And this A is actually a pointer. You can consider it as a pointer that is pointing to the first element of this array. Okay. So because of that, you can access the arrays using just like this, just using the index. That's one way of accessing the array. And the other way of accessing the array is using the pointers, where if you just write star A, that means you are accessing the first element of that array. Now, here in this example, we are assigning value 12 to the first element. And if you write it as A plus 1 star. Now, if you remember, why do we use star? We use star to access the so basically with this star, what we are doing is we are accessing the memory element with the given address. Now here, this is the address. We are accessing in the memory, we are accessing that specific memory element with this address. So here, this A plus 1 is pointing to this memory cell. Now, with regard to this array, so with A plus 1, what we are accessing is this element, the second element. This is called point arithmetic, where we basically play with the array positions, sorry, pointer positions. Now let's see this in example. I'm going to go to you can't see, right? Let me share the screen. Okay, there's some issues with the Can you see Visual Studio now?
Yes, sir.
Okay. So let's do example. this. Yeah, I'm going to create an array of 5. Let me do this. 2, 4, 5. And let's see. So as I mentioned, one way of accessing the arrays is using just the index. Let's see what we are going to print here, and let's see this one as well. Star A. Let's try out another one. Star A plus 2. Can somebody tell me what is going to be printed in this third line, that is line 70? Good. Arushan 3536. What should be the output?
3, sir.
Sorry?
3.
Are you muted?
No, sir. Hello, sir.
I can't hear you.
Hi, sir. Hello, sir.
There's something wrong with my audios. Yeah, Arushan, what is the answer?
Sir, 3.
Okay, let's see. Take some time because of the firewall. I might have to disable it. Yeah. So see, the output is 3, which is what we are doing here is essentially we are accessing the third element using the pointers, right? Okay, I hope this is clear. What else? Okay, the next one is the heap and stack memory. I'm going to explain that using an example again. Let's go on to the Visual Studio. Okay, what we are going to do is let's create a variable called x. Let's create another variable called y, and let's create a function. So let's call a function and let's create it over here. At any point of time, if you have questions, please feel free to ask. And inside this function, let's create a variable called a. Okay. Now we have in the main function we have x, y, and we are calling a function called a over here. And inside that we have a variable called a. So let's create one more thing. Let's create an array of integers. Can anybody tell me, in this line 10, where will this be created in the memory? I mentioned that last time. In the memory there are 3 we are using memory in terms of 3 sections. One is your fundamental code goes to the bottom, and on top of that we have stack, and on top of that we have heap. Depending on how you create the variables, it will be allocated to either stack or heap memory. Now in this particular example in line 10, can you tell me where will this be created in the memory? In which part of the memory will this array be created?
The heap.
Yeah, heap. Good. So let me ask you another question. This I may not have explained. Now here there are 2 things, right? Let me annotate and tell you. Let me annotate. Now regarding this line 10, so if you can see here, there's this p variable, right? and there's an array. So basically, there's a variable called p. There in memory somewhere it's allocated. There will be a pointer in memory, and also there will be a array, right, with 4 elements. 1, 2, 3, 4. Now this pointer p is pointing to this array. Now, as you mentioned, this array will be created in heap memory, right? That's correct. Now, my question is, where will this pointer be created? This one? In which memory this will be created? Anybody? This is a tricky question. You might get this in the exam as well. Anyone? 3585 Fernando? I should ask one of the people who haven't turned on their videos. For now, Fernando, can you tell me the answer?
Steve, sir.
Sorry?
Steve.
You mean stack?
Sorry, heap.
Heap. No, actually the answer should be stack, because now I mentioned anything we create, any memory that we create with the variable new will be allocated in the heap memory. Whereas now for example, what we can do here is what do I get done? Instead of doing this, now I think if I do it like this, it will be clear. Now here, you see, these are not, even though we write it in one line, these are two different actions, right? The first, we will create a pointer. Now, if you see here, there is no new keyword, right? This pointer will be actually created in the stack memory, because this is just this is just about creating a variable, right? But the type of the variable is pointer, but it's again a variable. So this one will be the line 10. In the line 10, we are creating a variable, and this variable p will be created in the stack memory. Whereas this line in line 11, we are creating an array. That array will be created in heap memory. So these are two different events, where the first we are creating a pointer that will be created in the stack memory, and second we are creating an array of integers that will be created in heap memory. Is that clear? Yeah. Okay. Let me clear the drawings. So yes, someone has answered it correctly in the chat. So it's stack, and the second part is in heap. Yeah, let's should we do next? Okay, let's do one more thing. Let's assign zero a value 4, and then let's return this array. Okay. Before going, I'm going to now debug and tell you another, explain how the memory is allocated, stack wise and heap wise. Before that, let me draw it and tell you. So let me go to annotations again. Yeah. So let me. So let's say this is our memory. Okay, let's say this is our memory. Our code goes to the bottom. We don't care about that. Now inside, on top of that, in the first stack, that will be a main. So whatever we have in main will be created here, and inside that we have X. I hope it's clear, right? And we have Y, right? Maybe I'll draw it again. It's not clear, right? I'll draw it again. So we have the whole memory like this, and bottom the code is there. So this might be a question that will be coming in the exam. I may ask you to, I may give you example code, and I may ask you to draw the memory diagram where the variables are, how the variables are allocated in the memory. So because of that, just my turn to observe this. So you have X, we have Y, right? And this will be the main stack, right? So everything over here is in the stack. And so then we have a function, right? So that function is over here. So this is the stack of function A. So each scope has a different, each scope is created differently, separately in the memory. And then on top of that, so inside the function A, we have a variable called A, right? So that is also in stack memory. Now inside the same function, we have a pointer P. So that's also in the stack memory. Whereas these four array, like this array with 4 elements, will be created in heap memory, right? So this is heap. So this part is heap, and he has a array. 1, 2, 3, 4. And this pointer is pointing to this array, right? Is that clear? So this is how your memory is allocated. Whereas now all this is stack. All this is stack, and the top one is heap. Correct? Hope this is clear. Now let's go on to let's debug this and see how we can whether we can visualize how the memory is allocated. I'm going to put a breakpoint over here. I'm going to put a breakpoint over here, and I'm going to run it. Since some of you are taking notes, this notation I forgot to mention. So earlier when we are accessing arrays, so this star A is exactly equal to A0, accessing A0, right? Now whereas star A plus 1 is exactly equivalent to accessing A1, okay? And as a general notation, star A plus I is equivalent to X, sorry, 3, only 3, equivalent to accessing ith element. Okay, this just for the notes. Okay, clear the drawings, go out of the annotation, and okay, now I have debugged this code, and we are at this point. Okay, so I have put the debug point over here, a breakpoint over here, and now the program has stopped over here. Now you see in this main stack, now you see X, the variable X is created, the variable Y is created, and the values have been assigned. So this is the stack of main. Now if we go into this, now with if you go into this function A, how you can go into function A is using this step into button, right over here. Can you see step into, right? If you click this, it goes to the function. Whereas if you had clicked step over, it won't go into the function. It will automatically it will run the function, and it will go out of the function. This step over is we go line by line, right? So we have, since we have gone to we have to click step into, we have come to this function. Now what we see over here, can you see the mouse? I hope you can see the mouse, right? So what we see over here is the stack of this function A. See, now the two variables, by this A is, right? Let me go. I don't know why A5 was there, maybe earlier, because I was using this for some other programs. Now somehow, now we see, you see, A, now we have created a variable A with the value 3, and then we have created a pointer, right? Up to now, only the pointer is created. Now if we go one more, you'll see that I guess the heap memory is not showing here. So you see the pointer piece pointing to an array of elements, 4 elements. I guess the heap memory is not shown here. And if we return from there, we come to here, whereas we don't see the memories that is allocated with this function name. So what we see here, now program is here, we only see the memory that's allocated for the main function. Okay. Now you might have this question. Now I mentioned last time the stack memory will be automatically deleted when we come out of a function, certain function or certain what is it called? The technical term is scope, right? So when we come out of this function A, whatever the memory that was created over here will automatically be deleted. We can't delete it. It's done by the system, the compiler itself. So because of that, when you're using stack memory, you don't have to worry about deleting the variables or the things that the variables, the arrays, whatever you have created, you don't have to worry about that. It will be deleted. It will be managed by the compiler itself. Whereas with heap memory, it won't be deleted. Whatever we have created here, now this array will be there in the heap memory unless we delete it, right? So now the disadvantage of that is, if you forget to delete these memories, or the arrays, or the variables, whatever you have created, at some point in time, the memory will be occupied. The memory will be get filled with all these arrays, and the program may crash because the memory, you may see a exception called memory out of bound, right? Because how you see this array the exception or the error is when the memory get filled, when you don't have space to create more variables or use more memory, you will see a exception called memory out of bound, right? So because of that, especially in programming languages such as C, C++, you need to remember, you need to delete whatever the heap memory, or if you want to delete, I mean, you might have a use case of using these arrays after some time, but if you don't want to use it in future in your program, you might want to delete these arrays, right? So let me show that with example. Now, if you remember here, what we have created is we have created the array of 4 in heap memory, and we have allocated, we have assigned the values 4 to the first element, and then we have returned that array, right? Now we can take this, whatever the returning array, we can assign it to another variable pointer called P, and then let's try to print what P0 is. Now, technically, because this is created in the heap memory, right? So we should, when we come out of this function, that memory should be there, right? So technically, we should be able to see output over here. So output of 4, right? Let's see. Take some time for the debugger to come up. So yeah, now we are over here. We go, let's just go over the line. I mean, we don't have to go to the function. Yeah, see, now we have gone over this line and the value is 4. Value 4 is printed. That means we have the access to this heap memory and it is not deleted, right? Now, what we'll do is let's just delete this. Can somebody tell me how to delete an array that is created in the heap memory? 3641 Kumar. Can you tell me how to create a array
Yes,
that is
delete square
Yeah.
bracket, delete square bracket, the name of the array.
good? So let's run it again. Okay, we are here. We just go to the function. Let's go line by line. So we have created the array of 4, and we have allocated the value 4, and then we just deleted, right? If you see, because we deleted, now it shows as unable to read memory, right? Now let's return and let's see. Okay, and we have come to over here. Let's try to print this. See, exception is thrown. See, exception is thrown because that memory is no more, right? Because we have deleted that memory is no more there in the in the RAM, and so because of that, there's an exception, right? So yes, that's a practical demonstration of how to use the heap memory and how when we delete that it's clear that it's not possible to access it. Just one more thing. Instead of creating this array in the heap memory, what if we let's create this one. Okay, now what we have done is instead of deleted this, instead of creating that array in the heap memory, now what we have done is we have created it in the stack memory, right? Clear? Because this new keyword is not used. So this will be created in the stack memory. Now let's try this. Ideally, what should be what here? Can someone tell me what should be the output? Let me ask someone. 3722, Richard. Can you explain what should happen here? What you expect to happen here? Richard, 3722, Richard MRM. I need an answer. If you don't know, just at least tell me that you cannot understand or you don't know. 3690. Can you hear me? 3690.
Hello, sir.
Yeah. Can you tell me can maybe explain what should happen here, or at least tell me what should be the output here. Better if you can. No.
Oh.
Tell me. Yes. Hello.
4, sir.
4. I mean, if we run this, probably it will print 4, but technically it shouldn't, because as I mentioned, now this memory is created in the stack, right? Now, when we come out of this function, right? Whatever we create in the stack will be gone, right? Correct? So when we return over here, whatever we created in the stack memory should be erased, right? That is not done by us, that's done by the compiler. But the thing is not like it won't happen right after. It happens when the memory, practically speaking, it happens when your memory is getting filled up. Now he will delete those variables that should not be in there. They are in the memory. Sometimes when we run this, we get the exception that the memory is not there, but no, most of the time it works. But theory wise, we shouldn't see this, because theoretically whatever we create in stack should be will be deleted when we come out of that particular the term is scope, right? We come out of the scope, that memory should be deleted. Let's try. So we are here. Let's go into the function. So you see now you can see an array of 4 created, right? The values are 4 and other 3 are garbage values, right? Because we only assign a value to the first element, whereas the remaining 3 are initialized. So you see some garbage values over here. See, right? Then let's return from there. So we have come to here. Yeah, see the values there. That's the issue. So we'll see a value. The value 4 is printed. So even if you see online, and if you see on the forum that is there on the online, what is mentioned is theoretically the stack memory should be gone by the time when we return from a scope, but practically speaking, because we have so much memory at our disposal and all, it is not, it won't happen right after. So that's why we see the value over here. But no, what you need to remember, and if a question comes in the paper, the expected output is that expected answer is that the stack memory will be deleted and an exception is thrown. No, we won't see a result or something like that. That should be the answer. Okay. Yeah, because the thing is, we shouldn't expect it to work like that. This works only at some times only it works. So when we code, we should expect the program to work all the time. So this is whatever happening here, it happens only in several times only. There could be some situation where we can't see a value and exception is thrown. So we shouldn't write codes to work in only some times or in some instances. So our program should work all the time, right? So this is something you need to remember. Okay, with that, I guess that's about the stack and heap memory. I have taken this note in my notes. I have written down that the question can come from the stack and heap memory. So this is advantage for those who attend the lectures. So you can take notes and can come prepare for the exam. Okay, so let's stop over here. Let's go to the presentation. Yeah, the stack and heap memory is done. Okay, this one. This is about changing the array size, right? So, should I do this with example? No, maybe I'll explain. Annotate. So this is about what we want to do here is we want to we know that with arrays the size of the array is fixed, right? So there could be some situations where when we are working with the array, we want to use more elements. We want to have more elements. This whatever the size that we have created is not enough. So in that case, in such situations, we need to create a bigger array, right? So let's see how it is done. Technically, it's not possible like with arrays. We can't have it, but there are some workarounds. That's just this is one such workaround. So with this, what we are creating is an array of A with size 5, right? So the size is 5. 1, 2, 3, 4, 5. And now what we want to do is we want to double this. We want to have an array of when we are working with this, our cells get filled and the space is not enough. We want to increase the size of the array. So let's say we want to increase the size of the array to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we can do is to increase the size of the array. Now the thing is, so if you remember, array is continuous, right? That means whatever we have created will be created in the memory continuously. So all these each cell is 4 bytes. So altogether this is 20 bytes, right? The size of array is 20 bytes. That will be created consecutively in the memory. Now, when we want to expand or increase the size, we can't guarantee that the remaining, let me use another color. We can't guarantee that in the memory, these next couple of cells will be free because these could be used by some other program, right? So because of that, we can't right away increase the size of the array. So how to do it is what we have to do is we have to create another array called temp, right? So this is temp with size 10, whatever the size you want. And the next thing you want to do is you want to copy whatever the element that is there in array A to temp. So we'll be copying each element, right, to the new array temp, right? So the size of the first array is 5, right? So we'll be copying all the elements to the new array. Now, so one way is we can just go with temp. Whatever for the remaining program, we can, instead of using A, we can use temp. But that's not possible sometimes, right? Because in the program, when you write the program, the codes, this variable is sometimes essential because later part of the program we might have used A, right? So if we want to change the variable, then we have to change all the variables. So now somehow what we want to do is we want to have another array A with size 10, right? So we need to have the same variable, the same reference. So now what we can do is now we have created a temp with a size of 10. So we can just maybe what happens if we do this? So we can assign temp to A, right? That's possible, right? Right. So what we are doing is, so basically we are asking A to refer to over here, right? Correct. So now that's possible and it will work, but the thing we have forgotten is this memory, this what we have created over here, right? Because this is in the heap memory, we haven't deleted it, right? We need to delete this one, right? Otherwise, this will be there in the memory forever until the program exits, right? So it's important to note that we need to delete this array. So how to delete the array is using delete square brackets A, right? Now I have a question over here. Now, when we do this, for example, when we execute this line, wouldn't A will be deleted? Shouldn't A, the pointer A, isn't it going to be deleted? So if it is going to be deleted, how can we use A again, right? Don't you have this question? Can someone answer why it doesn't happen? Why deleting now this line? Let's say this is 1, 2, 3, 4. This line 4. When you execute that, my question is, wouldn't the variable or the pointer A will be deleted? Wouldn't it be deleted? Can someone answer?
It won't be deleted.
Yeah. Why is that? Who's it?
As explained before, the array which points was in the heap, but the A variable was in the stack.
Yeah.
The pointer, so when we equal it to temp again, it will point to the new temp array.
Yeah. Correct. Yeah, that's the answer. Yeah, good. So the thing is, A is created in a stack. It's just a pointer. We can't delete a pointer. Or that is whatever we have created in stack, we can't delete it. So what we are deleting over here in line 4 is actually that array. Oh, this array. Yeah. So this is what we are deleting, right? Sorry. So these 5. This is what we are deleting. Not the pointer A, rather the array that A is pointing to, right? So yeah, that's the tricky part in this example. So hope it's clear to you. Yeah, so I think we have covered everything about one-dimensional array. What is left for us to do is two-dimensional array. So these two-dimensional arrays are very important in operations such as matrices. Now, I believe you're familiar with matrices, right? So in matrices, what we have is quite similar to what we this is actually a matrix, right? So this is a matrix, right? So it's actually a two-dimensional representation of array, right? Now, how do we create two-dimensional arrays? So this is example. So instead of earlier what we wrote was how created was A2, right? So this is a one-dimensional array. Now, when you declare it as A2 and with 2 square brackets, what we are getting over here is actually a two-dimensional array of. Now, the important thing to notice is this is the row. These are the number of rows. These are the number of columns. Okay, take note of that. These are the number of rows. These are the number of columns. So here we are getting 2 rows and 3 columns. Yeah, 2 rows, 3 columns, right? Yeah. So and how to access it? Of course, like this. So what we are accessing over here is now so let's say this is the array that we have created. Again, this goes with 0 index. So the first starting element is 0. So here, what the 1 means is the second row, right? The 0 is the first row, 1 is the second row. So we are basically looking over here, the second row, and this 2 means the third column, right? Over here. This is the memory cell that we are accessing, right? Correct? Okay. So even though you might think this is how it is actually created in the memory, it's actually not. So even though we have this representation of 2D arrays, but in the memory, still is 1D. So what happens, for example, if we take this one, where we have created an array of 2 by 3, in memory, what happens is it will be created consecutively. So the first two rows will be created consecutively. Likewise, let me double check that. Yeah. So the first two rows will be created consecutively, and then likewise it will go for no. Let me double check with the over here. We have a representation over here. I don't need to draw. So this is how it's created in the memory. See, this is how it created in the memory. So the first row will be created first, that means consecutively, and the second row will be created next, and the third row will be created after that. So it's row wise, right? However, when we are using it in our codes, we have the advantage of using as a two-dimensional array, because that work is done by the compiler. Now, whatever happens over here is done by the compiler. He managed to transform it into a 2D array, right? So we have the luxury of using it as a 2D array, whereas it's in the memory is actually a 1D array. Okay. And what else? Yeah, there's another way of creating arrays using pointers. Now, so this is now what we have already discussed is using the index wise, right? And this is actually created in the stack memory. So if you don't use any new keyword, that will be created in the stack memory. Whereas there is another way of creating arrays in the heap memory using pointers. So let me explain that. So we have 10 more minutes, right? So now, how do we create an array, that one-dimensional array using pointers? Like this, right? Let's say P equal new int. Let's say this is 3. So this is how we created a one-dimensional array using pointers, right? So when you want to create a two-dimensional array, so we'll have to use a double pointer. So what I mean by that is, so we'll be creating a array of pointers, right? So this is how you define a 2D double pointer. So here what we are doing is essentially, earlier it was int star, right? Earlier it was int type pointer. Now we are creating a pointer to pointer, correct? And over here as well, it should be star, correct? See the similarity. So earlier it was int star. This part wasn't there. This. So this part wasn't there, right? It was that the type of the variable was int star. That's a pointer. Now we are creating a pointer to pointer. So yeah. So we need have a pointer to pointer. Now so what happens is this becomes actually the data type. Like earlier it was int, now it is int star. That's a pointer, right? Because this becomes the data type, this over here also has to be int pointer, like in star. That's a pointer, right? Correct. Now so here what we have done is we have just created a set of pointers, but there is one more work to be done. It's not enough space. Let me do it over here. Let me use another color. So maybe I write it. So just P, the memory, how it happens is we have 3, right? The size is 3, and each element over here is a int star. This one is also int star pointer, These all now these are 3 pointers, correct? These are 3 pointers, right? What these pointers are doing, for example, no, this is a sorry P0, no, this is P, right? P0, P1, P2, right? So all these are pointers. Earlier, this was integers. Now here in this example, it was integers. Now these are pointers. Now these pointers are pointing to, this should be pointing to another set of arrays, which we are going to create later. We still haven't done this. So these will be pointing to another set of arrays. So that part we have to do. For that we need to have a for loop. Let's say just I'm going to ignore the data type. This should be int. Okay, I less than 3, so I plus plus, and so each pi should be linking to another set of, let's say this is 4. So yeah, correct. So what we are creating essentially is, so we are creating array, 4 arrays, like arrays with size 4. So these are integer arrays of size 4, and we are linking it to each pointer. So P0 is pointing to this one, P1 is pointing to this array, P2 is pointing to this array. Still, when we are accessing, it will be the same as this. So we can just access P, let's say P01. So accessing is same, the creation part is different. Now, can someone tell me, can someone tell me an advantage of using this? Instead of, no, we don't have to go through all this trouble, right? We can just create it using like this. No, just use int a and have 2 square brackets and then just give the sizes. Instead of just doing that, why do we have to go through all this trouble? Can you tell me one advantage? Of course, there's one that the most obvious advantage is this will be created in the heap memory. So that is there. On top of that, can you tell me another advantage? Someone? Yes, Anthony. Anthony, can you tell me advantage? Earlier you were in the first screen. Why you are in the second screen now? Did you change something?
No, sir.
Okay, can you tell me advantage of using this, doing all this?
No idea, sir.
Okay, someone, please in the chat. Sometimes I get this. Yeah. So, Lakshan, can you explain 3649?
Because we allocate memory in a heap, so we can change the size in runtime.
Yeah, sort of like not exactly what I was looking for. Maybe you intended to say the what I was looking for. So let me just, the advantage is, so this size, yes, yeah, this size, it doesn't have to be the same. It doesn't have to be 4. You can have this as 4, you can have this as 3, you can have this as 2, right? So in normal declaration, you can't do that, correct? Because we are plugging in new arrays over here, right? We are plugging in new arrays, right? These are new arrays. We are plugging into these pointers. The sizes can be different. So that's the main advantage, I would say, on top of the heap thing, right? So let's go into example. Let's do example.
Excuse me, sir.
Yeah.
So are they consecutive memory as the first stacking
No.
here?
No,
Or
because this is because these are heap, right? This is created in the heap memory. Heap memory is creation is random. We can't say this is continuous. It will be random. However, these three, now if you see these, maybe it's not clear, writing again and again in the same spot. Let me choose another color. There's the color palette. Maybe because the time is limited, I'm going to just write it away. So can you see this, right? I'm pointing to this array, right? This array, right? This will be created in the stack and this is consecutive. Can you see where I'm pointing? Jayakodi? Yeah.
yes, sir.
Okay. So because this is a set of pointers, all the pointers are created in the stack memory, right? So that will be continuous. Whereas what you plug in here, these arrays will be created in the heap memory, and that is not continuous. That will be created. Actually, the creation of variables in the heap memory is random. We can't say that will be continuous or anything. Probably, I'm not sure. I mean, these will be continuous because this is a consecutive for this array, right? So that will be continuous. But whereas these three, the three separate arrays may be created separately, right? They will be in random places in the memory. Okay, that's a good question actually. Yeah. So yeah. So let's do example. We have 2 minutes. Let's do example. Quick example. So, I mean, the creation of 2D arrays using the indexes is very straightforward. So I'm going to skip that. I'm going to go to creation of arrays using pointers. So, let's say this is 4. So we are going to create arrays over here. So what we have done here is, so we have created the array of double point array of 4. So if you as you remember, so yeah, I'll explain. So you'll have 4 cells, one array of 4 in the memory stack memory, and each cell we are going to plug in a new array of size 3, right? So we have a array of 4 in the stack memory, and and each cell will be a pointer, and for each pointer we are going to plug in an array of 3, which will be created in the heap memory. Now, instead of doing this, we can just have some random values as well. As I mentioned, that the sizes can be different. For the easiness, I just use 3. So each array will be of same size. Now, let's try assigning values. So I'm gonna just copy this because the time is over. So give me 1 minute. I'm gonna. So let's see how we're gonna assign values, because that part I couldn't do. So we need another variable for that. So this will be 3 because the second one is 3. Okay. So all we do is pij equal let's first assign a value 100. Okay, so this is how we initialize the array. Correct? Got it? And then let's just print it. In order to print, okay, let's run this. Is clear? So what we have done over here is we have created the array. So we basically first created the array of 4. That's row wise. So then for each cell in that row, we created, we plugged in array of size 3, which was created in the heap memory. And then we assign values over here. Here basically assign 100 to each one. So now then we printed it over here. We printed it, and the result is this one. See, right? So this is an array of size 4 by 3. Now instead of just assigning 100, we can just assign I by j. So that will be a so the row value and the column value will be multiplied and then assigned to the cell. Right? Yeah, like this. So that's it about 2D arrays. I hope it is clear. It was I was going a little bit fast, but because the time is over, I had to go a bit fast. So I hope it's clear. So please note the difference, like where these arrays are created, whether it is in the stack memory, whether it is in the heap memory. What's the advantage of using these double pointers? So please take note of that. And I think that's it, right? Oops. Yeah. So as a summary, what I have to say is there's more to learn in arrays actually. So learn about dynamic arrays. So we actually did one way of creating dynamic arrays using these double pointers. So learn about dynamic arrays. Then this vector classes. In vector classes, if I remember right, which was a recent thing. We can change the size of the arrays. That was the unique thing about vector classes, if I remember right. So learn about vector classes, and then of course how arrays are used in other programming languages such as Java. No, one difference with Java is you can't access arrays that's beyond what you have declared. With C, you can access what beyond what you have declared. If you have created an array of size 5, you can sometimes access the array of size maybe the 100 of elements. So that will be a part of other program. And of course, I want to emphasize this: do practical exercises. This will get into your memory only by doing. So the array part may be easy, so it might be easy, but going forward, when you go for these graphs and algorithms, the more you practice, that's how you get to know. And especially those who are planning on doing software, please try them. The arrays and these data structures are essential. One of the key interview question when you go for the trainings and the jobs, most of the time there will be a question from data structures. Now, other important things are object-oriented programming, and most of the time there will be a question from data structures and algorithms and object-oriented programming, etc. So even though these are some basic things, they expect us to learn these basics. And then if you have a solid foundation in this, if you know the basics well, it's always easy to learn the advanced thing. So because if you don't have the basics set up correctly, it's harder for you to learn these advanced things. With that being said, I'm going to wind up today. Now, if you have any questions, please feel free to put it in the LMS. Even now, if you have questions, we can take a 1 or 2 minutes, right? So I'm going to give you a 1 minute. So if you have questions, please raise. Maybe you can type in the chat. That's also fine. Oh, there's a question, right? The variables just created using new keyword is the only way to create variables in heap memory. Yeah, as of now, yeah. So the variable new is the key to create access the heap memory. Okay, so some of you was having power cuts, so that's fine. So I'll upload the videos by this weekend, so you can go through and prepare and then come to the next lecture. Yeah, so if you don't have questions, so let's wind up. So thank you very much for attending. Hope to see you next week. Okay, thanks.